This is Unit 6, Video 2, Practice with Polarity. So I'm going to kind of just go through a couple of problems on the board really fast, go through the Lewis-Dot structure to determine the polarity of the molecule. So here, if we were to go through and do the Lewis-Dot structure for carbon dioxide, we would get that we need to draw two bonds because the need is not equal to the available, and we would get this. So if we look at our central atom, we have no lone pairs on the central atom, and the two atoms connected to it are the same atom. So what's going to happen is we're going to get equal and opposite distribution of charge. So this is going to make this a non-polar molecule. It's also going to make it linear in shape because they can spread completely out as far away from each other as possible. There's nothing on top of the carbon or below the carbon that's going to fluctuate that distance. So this will be linear and non-polar. Here if we look at sulfur dioxide, this actually ends up being a resonance structure. So we can draw this many different ways, or two different ways. What we're going to do, and we're actually going to get a lone pair on the central atom when we do that. And we'll get that. Okay, this is what we'll get if we were to draw sulfur dioxide one way, and then if you were to draw it another way, you're just going to move the bond to the opposite oxygen, and you get another resonance structure. So if we look at the shape of this molecule, we're going to get, we've got 1, 2, 3 electron clouds. Out of the 3 electron clouds, we've got one lone pair. Well, we've got a lone pair. If we ever have a lone pair in the central atom, it's always going to make the molecule polar, even if we have the same thing attached. So if we were to look at, if we were to draw this molecule out, where we've got 2 electron clouds, one lone pair, we're going to get a bent structure. So if we were to draw this, the molecular geometry of this, you would get something like this. And what's going to happen is, I should draw the oxygen, is we're going to get a dipole pull down this way. These oxygens want to pull sulfur's electrons. So it's going to pull down towards the oxygens. So where we get a dipole, this is going to be a polar molecule. Okay, moving on to phosphorus tetrachloride. If we were to draw this, okay, we get this shape right here. If you were to first look at it without even drawing the Lewis-Dot structure, you might say, okay, well, it's got all the same atoms connected to it, so it's nonpolar. But remember, if there is a lone pair in the central atom, it makes it polar. We've got a lone pair in the central atom. Okay, but let's look at the shape of the molecule. We've got 1, 2, 3, 4 electron clouds. Out of the 4 electron clouds, we've got one lone pair. So what this is going to make it is trigonal pyramidal. So we're going to get something that looks like this. Okay, because we've got that lone pair up there, it's going to push the chlorines down. So what's going to happen is we're not going to get an even distribution of charge. So we're going to get a dipole occurring. Where's the center going down? I kind of butchered that a little bit. Okay, so this is going to be trigonal pyramidal, and it's going to be a polar molecule because we have lone pairs on the central atom, which is going to make a dipole moment. A dipole occur. Okay, if we look over here at C2H4, okay, before even drawing the Lewis-Dot structure, you can look at this and say this is a hydrocarbon compound. So therefore, it has to be nonpolar because all hydrocarbons are nonpolar compounds. But if you didn't recognize that and you were to draw the Lewis-Dot structure for it, you would get something that looked like this. Okay, if we were to look at the molecular geometry of carbon, carbon's our central atom. So we've got 1, 2, 3 electron clouds. Out of the 3 electron clouds, we've got no lone pairs. So this is going to be a trigonal planar in shape. So if you were to draw this, we're going to get something that looks like this. This is a symmetrical molecule. So we're going to have mirror images if you were to cut this in half. So we're going to have the exact same thing over here. We're going to have 1, 2, 3 electron clouds. Out of the 3 electron clouds, none are lone pairs. So we're going to get trigonal planar in shape. So this is a nonpolar molecule.